Good day and welcome to School of Chemistry. Today we'll be looking at the concept of hybridization. When you hear hybridization, it talks about orbitals should come into your mind, how orbitals overlap to form bonds. But before we look at hybridization, I want you to understand that different things in nature mix together. For example, salt can mix with water and you have a salt mixture. Sugar can mix with water and you have a sugar mixture. You can mix rice with stones and you have a mixture too. So in layman terms, hybridization is simply the mixing of orbitals. Simply the mixing of orbitals. Now, when your S and P orbital mix, they form a new type of orbital called SP orbital, and we call this the hybrid orbital. So in simple terms, what is hybridization? Hybridization simply is the mixing of orbitals of similar or equal energy to form new orbitals referred to as hybrid orbitals. Now, when two orbitals mix, these orbitals must be of either equal or similar energy. They will form a new orbital completely and refer to this orbital as what? Hybrid orbitals. Now, for example, or in electronic configuration now, we'll talk about quantum chemistry. You know that you have your first share with 1s, second share 2s, 2p, third share 3s, 3p, 3d, and so on. Now, this energy level has a particular amount of energy that is different from this energy level. Therefore, the orbitals in this energy level cannot mix with this. But the orbitals within same energy level, like energy level 2, can mix. Energy level 2 and 3 cannot mix because the energy level are what? Different, they are not equal. So it's only orbitals in the same shares that can mix. That's what we talk about, equal or similar energy. Now, within the same energy level, we know that the s orbital and the p orbital do not have equal energy. The s orbital is lower in energy than to what compared to the p orbital, but they have similar orbital, therefore similar energy, therefore they can what? Mix. Now we have different types of hybridization, but in this discussion we'll be only looking at the hybridization of carbon. Now let's look at the electronic configuration of carbon. Carbon has atomic number 6. 1s, 1s2, 2s2, 2p2. Now, this is one energy level. This is another energy level. Now, the orbitals in this energy level can mix. So, we can have hybrid orbital in this orbital, in this energy level. Now, in the ground state of carbon, we have the ground state of carbon, we have the 1s2, we have the 2s2, and then we have the 2p2. We have the px, the py, and the pz. the PS has 1, the PY has 1, there's no electron in the PZ. Now, in the excited state, we have one S2, which will not be involved. We have the 2 S2, which will now have only 1 electron, and then we'll have the 2 P3, now when carbon is excited, when it gains energy, one of the electrons in the 2s will move to fill in this vacant PZ orbital. The simple reason is that this half-filled orbital gives stability to what? The carbon atom. So in the excited state, it can move and stay in this state. It is from this state that we'll be understanding what? The mixing of orbitals. Now we have 3 types of hybridization of carbon. Hybridization of carbon. One is the SP hybridization. Two, we have the SP2 hybridization. 3, we have the SP3 hybridization. So these are the 3 types of hybridization. Now let's look at the SP hybridization. In the SP hybridization, it involves the mixing of one s orbital and one p orbital. How does it happen? Let's look at the ground state configuration of carbon again. We have the 1s with 2 electrons. We have the 2s, 1s2 with 2 electrons, and then we'll have the 2p with 2 electrons. In the excited state, we're going to have 1s2 with 2 electrons, 2s2 with 1 electron. Then we'll have 2p3 with 3 electrons. Now, in the mixing of orbitals, it's going to involve 2xy here. It's going to involve only 1 x orbital and 1 p orbital. Remember, this is px, py, and pz. So in the mixing, we're going to have 1s2, which is still here. Then here, we're going to have 1, 2. This orbital is sp hybridized. This one is what? sp hybridized. Now this one s orbital is here, 1 p orbital. So we are still left with 2 p orbitals unhybridized. And this is going to be the px and the py. So these are unhybridized, that is unmixed orbitals. Why this is what? sp hybridized. Now, looking at the nature of this, the character of the sp hybridized is 50% x orbital character and 50% p orbital character, and the angles of this orbital are directed at 180 degrees away from each other, and it has a linear shape. The sp hybridized orbitals have a linear shape, and the orbitals are directed 180 degrees away from each other. Let's look at the next one. Example of sp hybridized molecules. Compounds of beryllium like Bf2 is F2 sp hybridized, and all compounds of they are with carbon-carbon triple bonds. Carbon-carbon triple bond like ethyne, H2 1 2 3, H2 is hybridized, is sp hybridized. Now another example type of hybridization is SP2 hybridization. SP2 hybridization involves the mixing of one s orbital with two p orbital to form three hybrid orbitals. Now, let's look at carbon again. The ground state, we are going to have one s2 with this configuration, two s2 with this configuration, and two p2 with this configuration, px, py, pz, 1 1. In the excited state, what you have for carbon, in the excited state, we have one s2 two s1 then you have 1 2 1 2 3 2p3, where you have the px, the py, and the pz. Then in the hybridized state, remember this is sp2, that means one s orbital is mixing with two p orbital. This one s will mix with two p orbitals. So here we're going to have excuse me, one s orbital, two p orbital. So this one s, this electron will come here, they are mixing, then 2 1 2 3. So we are left with one unhybridized orbital, which will be our pz. This is hybridized sp orbital, hybridized sp orbital, hybridized sp orbital. So this is unhybridized, while this is SP2 hybridized, meaning one s orbital mixed with two p orbital. You can see this example of this compound, you can see it in compounds of carbon-carbon with carbon-carbon double bond. For example, carbon-carbon, for example, ethane, which is a C2H4. Structure is 1 2 H2 H2. These are carbons of which they have this double bond. It's an example of a compound with SP2 hybridized carbon. Let's look at SP3 hybridization. SP3 hybridization. In SP3 hybridization, we have one s orbital mixing with 3p orbitals. Let's see how it happens. We have the ground state of carbon with 1s2, 2s2, 2p2, and the excited state, we have 1s2, 2s1, and 2p3. Okay, 2p3, sorry, 2p2 here. So it's only two orbitals that will be filled. Px, Py, Pz. Px, Py, Pz. I think we are fine now. Now, in the hybridized state where we have mixing of orbital, remember in the hybridized state, in this case, one s orbital is mixing with 3p orbitals. So this one s orbital will mix with the 3p orbitals. One, two. Okay, the one s will come, and these three orbitals will come. So here is sp hybridized, sp hybridized, sp hybridized, sp. We have four hybridized orbitals, and this is SP3 hybrids, hybrid orbitals. So this is it. Now looking at this, in this type of hybridization, the molecule or the hybridization will have 25% S character and 75% P character, and the angles here are 109 degrees, 28 minutes away from each other. They are directed at 109 degrees, 28 minutes away from each other, and their shape is a tetrahedron. They are tetrahedral in shape. The shape of the SP3 hybrid orbitals are tetrahedral in shape. Examples of substance that have SP3 hybridization are substance of with carbon-carbon single bond. Example, methane, which is CH4. We're going to have something like this. 1, 2, 3, 4. It is what? SP3 hybridized. Is that okay? Now, before we continue, if it's your first time visiting this channel, please click on the subscribe button so that anytime we will have a new update, you'll be notified. And do not forget to like, comment, and share this very discussion so that other people can have access to it. All right, let's continue. Let's look at this example. For example, in the formation of methane, we have an orbital here, a p orbital here, we have an orbital here, and then an orbital here. So each of these orbital has an electron that an x orbital can overlap with. Okay, no, let's look at something else. Now, how do you know the type of hybridization? Type of hybridization in a molecule. do you know the type of hybridization given in a molecule? Now, it's very simple, and that's what we're going to be looking at. If you are given a molecule, how do you know the type of hybridization? First thing, you're going to treat a single bond, a double bond, a triple bond, and a lone pair. Each of these is 1 point. Be you a single bond, a double bond, a triple bond, or a lone pair, you are 1 pair. Now, if you have 4 points, 3 points, or 2 points, we determine which of the type of hybridization you have. For example, if you have 4 points, it's going to be SP3 hybridized. You have 3 points, it's going to be SP2 hybridized. You have 2 points, it's SP hybridized. So let's look at some example and see which type of points, how many points there are, and what type of hybridization we have there. And let's put them together. We have methane. 1, 2, 3, 4. Let's see what type of hybridization is in methane. Remember that each bond is 1 point. So here we have 1, 2, 3, 4. So each of these 1, 2, 3, 4. We have 4 points. So this is SP3 hybridized. Now let's look at ethene. Ethene. This is ethene. It's going to be 1, 2, 3. 1, 2, 3. So each of this carbon here is what? This one. 1, 2, 3. 3 point is SP2. Remember, 1, 2, 3. So each of this carbon here is SP2 hybridized. Let's look at ethyne. One. So let's calculate. Remember, each type of bond is 1 point. So this is 1, this is 2. So this carbon is SP hybridized, 2 points. 1, 2. This carbon is what? SP hybridized. Now let me give you this as classwork. You have a compound like this: 1, 2, 3, double bond, 1, 2, 3, 4. 1, 2. Now, I want you to tell me if this is your carbon 1, 2, 3. Tell me the type of hybridization for each 1, 2. Okay, 1. The type of hybridization for each of this carbon. Type of hybridization present for each of this carbon. Now, but before I close, let me show you this one too. We have ammonia. Ammonia with a lone pair. Let's count. This is 1. This is 1. This is 1. And this is 1. So this is 1, 2, 3, 4. There are 4 points. So ammonia is SP3 hybridized. Now you can tell me the type of hybridization in each of these elements. Leave the answer in the comment section. I'll be reacting to each and every one. And do not forget to subscribe, like, comment, and share.